Introduction to K-means clustering. K-means clustering is an unsupervised learning algorithm that is used to solve the clustering problem in a machine learning or data science. Hello everyone. In today's video, we're going to be starting the next topic of introduction to clustering, which is K-means clustering. K-means clustering is also one of the clustering methods that we use in our daily life. So let's learn more about it and how we can use it. Now the K stands for the number of clusters. Example K2, K3. Number of clusters means number of groups. Now the objective of K-means is simple. Group similar unlabeled data points together and discover underlying patterns to create new groups and find out more patterns or similarities between them. Now the steps of K-means clustering. So step 1 is to select the number of a k to decide the number of clusters. Select a random k points or centroids. Now assign each data point to their closest centroid, which will form a predefined clusters. Now step 4 is to calculate the variance and to place a new centroid of each cluster. So we're going to repeat the third step, which means reassign the data points to the new closest centroid of each cluster. The elbow method. In the elbow curve, we actually divide the data into 1 to 10 clusters and calculate the WCSS for each cluster. The WCSS within cluster sum of squares is the sum of square distance between each point and the centroid in the circle. Now we plot this WCSS on a graph versus number of clusters in which data is divided. Now with the increased number of clusters, the WCSS value will decrease, and the point to where sudden drop of the WCSS will happen is the elbow point or the correct value of K. Now the applications or where they are used. E-commerce, classifying customers by purchase history or clickstream activity. Healthcare, detecting patterns for diseases or success treatment scenarios, or grouping similar images for image detection, like cancer images or lung cancer images. Now, finance, detecting fraud by detecting the anomalies in the data set means sudden change of behavior. For example, detecting the credit card fraud by an abnormal purchase pattern. Like you are on a website, Amazon, and you want to buy something. And say that the Amazon website have been keeping track of you, that you are coming to buy here every week. Now, suddenly, if you are not at home and a hacker attempts to take over your account, and buys many things in one day or new things every day, then the Amazon will detect that this is an abnormal purchase. Now, technology building the network intrusion detection system that aims to identify attacks or malicious activity, like what do you say, credit card fraud detection to check out, and now the meteorology to detect the anomalies in the sensor data collection, such as the storm forecasting. It can either be weather predicting, e commerce, healthcare, finance, technology, and meteorology. The benefits and the drawbacks. The benefits, drawbacks. Now, the benefits are that it is a very simple to implement. It is changeable to a huge dataset and also faster to large dataset. The k-means clustering adapts the new examples very frequently, means very often, and it generalization of clusters for different shapes and sizes. So it has clusters for everything, you can say. Drawbacks that it is sensitive to the outliers, means missing values. Choosing the k values manually is a very tough job, you can say. And as a number of dimensions increases, means the cluster 2D, 3D, 4D, the scalability decreases. Scalability means the changeability. We are now going to move on to the coding part, which is going to be in the next video. So keep watching.